Hey guys, in today's lesson we are going to go ahead and combine all the things that we've been talking about and learn a little bit of new stuff, but mostly stuff that you already know. We're going to go ahead and start talking about proofs in a more formal way. So far we've only done baby proofs, so we're heading towards something that would be more legit, something a mathematician would be really proud of. So in our notes today we're going to prove parallel line and angle relationships, okay? So taking a look at this example, we have to solve for x and justify each step, and we are given that the measure of angle AOC is equal to 139, and then it gives us this diagram over here where AOC is this large angle, and then we have two smaller angles contained inside of it. So whenever you're doing a proof, don't forget you always want to start with what's given or what you see. And it's also a good idea in proofs to number them so that way you can match each statement with each reason, because sometimes your statements take up more than one line. So for number one, I'm going to start with what's given to me. I'm going to say the measure of angle AOC is equal to 139. And I'm also going to number the reason for that so that way I know that this matches this. The reason, because it's given. Okay? It's literally there in front of my face. So, moving on. Now that I know that the angle AOC, that measure is 139, I'm going to use the idea, okay, well, if this is AOC and these things are inside of it, together they should add up to make 139. So let's write that down. We're going to say x plus 2x plus 10 is equal to 139. And I'm allowed to say that because of that new postulate we just learned. It's called the angle addition postulate. Because we're dealing with an angle, and we're saying if we add the two things inside, we get the whole. And I'm just going to use POST for postulates, just post, because remember, mathematicians are lazy people. So, number 3, let's do the math. We know typically most people just combine like terms first, so I'm going to say x plus 2x makes 3x, still got plus 10, and still have 139. So, my reason, I just combined like terms. That's all I've done. Combine like terms. All right. So now that I've done that, next step, after I combine like terms, you're probably saying, let's move 10. So we'll move 10. Whatever you do to one side, do to the other. And you're going to get 3x is equal to 129. And what did we do? We subtracted, so we used the subtraction property. Now, the subtraction property, we have to be careful now to differentiate between equality and congruence, because we actually have two of those now. So I'm going to say of equality, because I am literally using an equal sign in my problem. Okay? If we'd use congruence, I'd say of congruence, but I'm not, so we're using equality. Number 5, we have 3x equals 129, so I'm going to go ahead and divide both sides by 3 to find that x is equal to, you might need a calculator, 43. Okay, and this is because of the division property of equality, because we divided. And there we go. We are actually all done with that proof already. Okay, so that looks very nice. Hopefully yours looks just as nice, if not better, because my handwriting's a little bit off since I'm working on an iPad. So, next example, we want to solve for m and justify each step, and we're given that line segment XZ. That's what that little bar at the top means. Line segment XZ equals 32. And remember, XZ goes all the way, so this whole thing is 32. And I remember that these two parts, since they make up the whole, I should be able to add them to make 32. So, doing our proof, though, since we have to justify each step, okay, number 1, we are given that line segment XZ is equal to 32, given. And from there, I'm going to go ahead and use the idea that if I add up the two pieces inside, the XY and the YZ, I should be able to get the whole thing. So I'm going to say 2m plus 5m plus 11 will equal 32 because of the segment addition property. Remember, we're dealing with a segment, not an angle this time, so it's the segment addition, not property. I should say postulate. Excuse me. I'm sorry. A segment addition postulate. Boom. Okay. Now, do the math. Combine like terms. 7m plus 11 equals 32. And that's because we combine like terms. And then we're going to say, okay, I've got 7m plus 11, so let's move the 11. Whatever you do to one side, you do to the other. 7m is going to be 21. And that was the subtraction property. And again, don't forget to include of equality since we're using equal signs here. There we go. And last step, divide both sides by 7 and to say m equals 3. Because we divided, we're using the division property of equality. Now, so these two proofs that we just did are very similar to the baby proofs we've already been practicing, okay, where we're just basically doing some math inside. The more formal proofs get a little bit trickier because it's not as clear as to what steps you should be taking next. But we will work through it nice and slow. Now, remember, all postulates and axioms you don't have to prove. They're taken for granted. But when you get something like the vertical angles are congruent theorem, theorems have to be proven, okay? But once we prove it, it's been done. So we won't have to prove it again and again.